Okay, lads, so we're solving basic algebra equations. This is from exercise 10.3 in your books, and it's questions 1 to 12 is what I'm going to do. So the first question. There's the first question. You're going to try and get x's to one side and the numbers to the other. One thing that I want to see in your work is that the equal sign should pretty much stay under each other all the way down. And that way then it gives you a clear picture as to what the left and the right hand sides are. Okay? Now you don't need to put in that dotted line, you don't need to write in right and left, but it should be fairly visible from the work that you do. What I tend to say to people is that as a general rule, bring the x's to the left hand side and bring the numbers to the right hand side. And if you're having trouble with this, a good thing to do is circle what's going to move and draw an arrow for yourselves. And if you find that that arrow crosses the broken line, well then it must change sign. So the 4x will just drop straight down. I'm just going to bring it down for a bit of space. And the plus 6 will drop straight down. And you'll notice there's no sign change there because neither of them have crossed the broken line. This 3x over here, this one that I'm talking about, it's really important and it'll never be stated for you, but you have to understand that's a plus 3x. So because it's crossing, it will become a minus 3x. The same thing here, we can see the plus that goes with the 5. So it changes sign to a minus. You can do the next bit on your calculator. 4 minus 3 gives you 1x. Again, you can do the right hand side on your calculator. Minus 5 plus 6 is 1. So in other words, 1x is equal to 1, or just x is equal to 1. Question 2. So again, you'll notice that the equal signs are going to come down underneath each other. The 4x that was on the right hand side moves across to the left. So it crosses over that imaginary broken line for us. So it becomes a minus 4. The plus 8 that was on the left hand side moves across the imaginary broken line, so it must change to a minus. Again, nice and simple, so x is just equal to 2. Same thing, keep the equal signs underneath each other. So it's minus x, remembering that's a minus 1x. 12 minus 6, or you can leave plus 12 minus 6, whatever helps your understanding. X is equal to 6. Question 4. And you'll notice when I'm doing these, as I move on to the second line, I tend to write down the stuff that isn't moving. And that way then I know that anything that I haven't written down, that is going to move. And if it is going to move, it has to change sign. Divide both sides by 3. X is 2. Okay, question 5. So again, you saw me write down what's not moving, so the 7x and the plus 18. The 3x is moving. When I moved it across, I changed its sign. So 4x is equal to 20. Divide both sides by 4. X is equal to 5. Question 6. So again, I'm going to write down anything that's not moving. The minus 2y that's on the right is going to move. It's a minus on the right, it must be a plus on the left. Remember, the minus 1 and the 13, they're not being multiplied. It's minus 1 plus 13, or 13 minus 1. So the 6y is staying where it is. The minus 9. Notice, lads, it's minus 9 that stays, not just 9. You have to include the sign that goes with the number as well, or the algebra. Divide both sides by 2 and minus 1, because the signs are different when you divide. At this stage now, it's getting quite repetitive. You should notice that my setup, my approach to the question is the same every single time that I do it. All of the equal signs are staying underneath each other. I write down the stuff that's not moving first, then I deal with the stuff that is going to move. Number 9. Again, guys, sometimes people get a little bit confused with a question like this because there's so many minuses in there. Remember, write down the stuff that is not moving. So in this question here, it's the minus y and the 6. Go to plus 2y and plus 8. And when you feel that your question is a little bit odd, just take your time with it. There's no panic, there's no rush. And just in terms of finishing that, you can say 1y is 14, or you can just say y is 14. Both of them are acceptable. You notice as well that I'm not bunching them together. I'm not bunching my work together. It's quite spaced out. It's easy for me to look back over it. This line here, remember, you can just use your calculator. Okay, use your calculator twice. That'll become a plus a or a plus 1a, and then this will be a plus 5. So a is minus 1, dividing both sides by 4. Last question. X is 2. Just before we finish, I just want to make it very clear to you what is actually happening. Okay, now we talked about this in class yesterday. Taking a very simple question, something like that. What I've told you, or sort of our quick way of doing it, is that x will be equal to 4 minus 2, because that plus 2 is crossing the equal sign, or in other words the imaginary broken line running down the middle, and then x is equal to 2. But strictly speaking, what's happening is, because I want to just have x on its own, so in other words that plus 2 is stopping me. So what I do is I take 2 away, because obviously that's worth 0, and if I do that, I'd be left with just x behind. But what I do to one side I must do to the other, so I have to take away 2 there as well, or subtract 2 there. So what I do to one side I must do to the other, and 4 minus 2 is still 2. Now you can see that the answers are still the same. What I've described to you there with adding and subtracting to both sides, strictly speaking, that is the correct way to do it. Okay? But just to move things along and to speed ourselves up, the trick that we use, or the little rule that we say, is if it crosses that imaginary broken line, it changes sign. Okay? Nothing just changes in maths for the sake of it. There is always a reason, and I just want you to be aware of it and to understand it. Okay?